AOPS number 3015.36. Find the sum of the total number of digits in each of 2 to the power of 2006 and 5 to the power of 2006. So if 2 to the power of 2006 is equal to a times 10 to the power of n, and 5 to the power of 2006 is equal to b to the power of 10, b times 10 to the power of n, that means 2 to the power of 2006 times 5 to the power of 2006 is equal to ab times 10 to the power of n plus n, if you multiply these two together, which is equal to 10 to the power of 2006. So 10 times 10 to the power of n plus n is equal to 10 to the power of 2006. So that means n plus n is equal to 2005. So n plus 1 plus n plus 1 is equal to n plus 2, which is equal to 2005, plus 2, which is equal to 2007. AOPS number 3015.41. If the integer 152ab1 is a perfect square, what is the sum of the digits of its square root? So since 300 squared is equal to 90,000, which is less than 152,000 ab1, which is less than 160,000, which is equal to 400 to the power 400 squared, that means the first digit is 3 of the square root because this is in between these two. So then if we try 380 squared is equal to 144,400, which is less than 152,000 AB1. So that means the first digits are 38 or 39 because this is 380 and it's greater than this. So the first digits have to be 38 or 39. And since the last digit is 1 because it's AB1, that means the square root ends with 1 or 9 because only 1 and 9 multiplied by each other ends with 1. So the only possibilities can be 381, 389, 391, or 399. So if you test all of them, 389, first we test 389 because 380 is only this much, so we're just estimating 381 squared probably isn't this much yet, so we'll first start from this. So 389 squared is equal to 151,321, which is still too small. And 391 squared is equal to 152,881, which matches this one, 152ab1. So the sum of the digits of its square root is 3 plus 9 plus 1, which is equal to 13. AOPS number 3015.44. The sum of two prime numbers is 20. What is the greatest possible product of these two primes? So since the sum of these two primes is 20, that means it can be expressed, the two primes can be expressed as 10 plus x and 10 minus x. Since if you add these together, the x's cancel out and it'll be 20. So the product of these two primes would be 10 plus x plus times 10 minus x, which if you expand it, it will be 100 minus x squared. So then if we try if x is equal to 0, 1, or 2, at least one of 10 plus x or 10 minus x is composite. So like for example, if x is equal to 0, then 10 plus x and 10 minus x are both 10, which is composite. And if x is equal to 1, it's 11 and 9 is composite. And if it's equal to 2, it's 12 and 8, which are both composite. So then if we try when x is equal to 3, these two, 10 plus x and 10 minus x, are 7 and 13, which are both primes. So that means the greatest possible product of these two primes is 7 times 13, which is equal to 100 times 3 squared, which is equal to 91.